1.
Alright guys, so lesson 2.2.1, we're going to talk about systems of equations. This should be review from the end of last year, end of 8th grade. So I'm hoping that you'll remember this pretty easily, but we're still going to go through a couple examples together. So two equations that are solved together are called systems of equations. The solution to a system of equations is the point or points that make both equations true. In other words, graphically, it's where the two lines cross. Systems of equations can have one solution, no solution, or an infinite number of solutions. Finding the solution to the system is important for many real-world applications. All right, so a couple of key concepts. You can pause and read that. The main two methods that we're going to talk about in this lesson are substitution and elimination. The third one is graphing. But again, we're not going to really go through graphing because hopefully you can graph two lines at this point and see where they cross. So substitution method, make sure you solve for one of the variables and then you plug that solution into the other equation for that variable. I'll show you an example of that in just a second. Solve for the second variable and then plug back in to find the original. Elimination is going to work much the same way except you're canceling out one of the variables. Solutions are written as an ordered pair x, y. If you get a statement such as 9 equals 9, all the variables cancel out and are gone, then that would be infinitely many solutions. And if you get a non-true statement such as 4 equals 9, that means there's no solution over the lines are parallel. Okay, check your answers by substituting x and y back in. And let's take a look. It says solve by substitution. So we're going to specifically look at substitution here. What you want to do is you want to look and say, okay, can I easily solve one of these equations for x or y? And the one I immediately am drawn to is the bottom one, because if I were to add y to both sides, then that becomes x equals y. That tells me that x and y are the same. So what I'm going to do now is go back to the top equation, x plus y equals 2. Well, I know that x and y have to be the same thing. So I'm going to take the y, really you can do it either way. I'm going to take the y and I'm going to replace it up here with what it's equal to, which is x. So x equals y, right? So that means I can now rewrite this as x plus x equals 2. The reason I can do that is because that y right there and that x right there are equal to each other according to this right here. Okay, and I got that from the second equation. Okay, that allows me to say, okay, well, x plus x is 2x, and therefore when I divide by 2, I get x equals 1. So 1 is my x value. So I'm going to write my point out here, 1 and then something. Now, to get my y value, I have to go back and plug it in. I'm going to plug it back into both to make sure it works, but I need to plug it back into one of them to make sure. So I'm going to plug it back into this right here, x equals y. Okay, well, if 1 equals y, well, there you go. I've already solved it. So they both have to be 1. Now, let's check that point to make sure it's true. So 1 plus 1 equals 2. Well, 2 equals 2, so that's true. And then 1 minus 1 equals 0. 0 equals 0. Check, check. Now, something I saw in the last couple of problems or last couple of lessons that some people were doing, misunderstanding here. When you go back in and check and you get 2 equals 2 or 0 equals 0, that doesn't mean infinitely many solutions. You already found your one solution. That was up here. That's what you got when you did this. Okay? The check should give you a number equal to itself. Because that's the whole idea, is it makes the thing true. It makes the thing work. It is where they are equal to each other. Okay? Does not mean you got infinitely many solutions. Just because the check looks like this. This part over here, if we had 1 equals 1 over here when you were actually solving it, that would indicate infinitely many solutions. Alright? So I'm going to pause the video there and then we'll go through the next two on a separate video, the next two examples.